Hi, 7th grade. Welcome back. I hope you enjoyed having a little bit of extra time to catch up on any work. In math, you guys actually are doing awesome. Almost all of you have everything in, so I'm really proud of you. I hope you enjoyed the no extra homework days. So now we're back at it after that nice break, and we are jumping in with section 4 of chapter 2. So we're going to be talking about exponents and division. So I know it's been a while, but we've been working with exponents already. We were doing some scientific notation. Do you remember that in the beginning of chapter 2? We were multiplying numbers with scientific notation. Hopefully that's kind of coming back. But today we're going to be talking about division. Okay, division. So we're going to start with this first example, okay? So 7 to the 5th, what that means, if I was to show that, it means 7 multiplied by itself 5 times. So I'm just going to actually write that out. So 7 times itself 5 times. Okay? And then 7 to the 3rd power is 3 of them. Okay? And we know that when you have the same number over itself, that's equal to 1 in division, right? So 7 divided by 7 is 1. This equals 1. 7 divided by 7, that's another fraction equal to 1. And then lastly, there's one more fraction, 7 over 7 equal to 1. So if I was to multiply this, I now have 7 squared, okay, to the power of 2. I have 2 of them. And on the bottom, I have none. I mean, I have a 1, right? Because these all turned into 1s, okay? So visually, I want you to see this picture. You're not gonna have to show all this work once you understand today's lesson, but I wanted to start with that visual, okay? So now that we've seen it, we wanna come up with a bit of a shortcut, okay? We're on page 82. I know that's not staying in the frame. So if your books are open, that's where I'm at. When we divide exponents, and they have the same base, we subtract the exponents. Okay? So we're going to take a look at that same problem and do it again. Okay? So if we have 7 to the 5th power divided by 7 to the 3rd power, when we divide exponents that have the same base, we're going to subtract the exponents. So here we have 7, and then our powers are 5 minus 3. Right? So we had a 5, and we're subtracting 3. And that equals 7 to the 2nd power, which is what we got up here. Okay? So remember, sometimes this concept is like hard for people to understand, which I get. I mean, it is new. But we want to remember that last week when we were multiplying exponents, if we had had 7 to the 5th times 7 to the 3rd, we were adding exponents, right? Oops, 3. 5 plus 3. So our final answer when we multiplied was 7 to the 8th. Okay, so when we were multiplying, we added them. So it does make sense that if we're dividing, we're going to subtract them. Okay? Sorry, I know I'm trying to back it up a little. Almost done all the way. Okay, So let's keep doing them. Okay, so this was an example of some numbers. So now let's take a look at some algebra. Okay. If we have a to the m power divided by a to the nth power, our answer, because our bases are the same, is a to the m minus n. And there's no other math we can do unless we have numbers, okay? If they're variables, that's as simplified as it gets. Okay. Let's try another one. M to the 12th power over m to the 5th power. We're dividing. The bases are the same. They're both m's. So we're going to subtract the powers, the exponents. So that means we're going to take m to the 12th and subtract the other power, so minus 5, which means we get m to the 7th. If you're struggling with this concept, which sometimes people do, go back to this first example and show your work, okay? Show your work until it makes sense. So for this one, that means I have to draw 12 m's. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 over 5 of them, right? And then I'd cancel. I don't have to make ones every time, but right, like m over m is equal to 1, 1, 1, 1, until I don't have any more on the top and bottom to cancel out. And I'm left with 1, 2, 3, 4, 5, 6, 7, m to the 7th power. Okay, so please remember, if I'm putting it in your notes, you should be copying it. You don't have to do this for your homework. You do have to do it for your notes, okay? Okay, when you're caught up on that, the other main idea, so when we're dividing, we're subtracting, the next one is that anything, whether it's a variable or a number, to the 0 power is equal to 1. Okay? So let's take a look at that. Anything, so I put a little asterisk, variable or number to the 0 power equals 1. And we're going to take a look at that. Let's say we have, if we make a math problem, 3 to the 5th divided by 3 to the 5th. Okay? If you wanted to draw them, right, if you wanted to visualize them, we would make 5 3's over 5 3's. And those would all cancel out. There's a numerator and a denominator of the same for all of them. It's like a match, right? There's a pair. So we're left with just an answer of 1. So that makes sense, okay? What gets tricky is when you take it the shorthand way. So same problem, 3 to the 5th over 3 to the 5th. And we do what we learned today, which is to take the beginning, so 3 to the 5th, and then subtract the 2nd power, minus 5. 3 to the power of 5 minus 5, when we simplify, is 3 to the 0 power. So this is not a good answer. You know, like when you were learning fractions and you had to reduce? So if you left a fraction in like 4/8, it was not correct because it was not simplified all the way down. This is the same kind of idea. So 3 to the 0 power is not a good answer because anything to the 0 power is equal to 1, okay? So that means if you have anything, right? A to the 0 power, that equals 1. 1 million, let's say 298,000 to the power of 0 is equal to 1. Okay? Anything. Okay? So hopefully that makes sense. Here's the last piece. We did one in the beginning where the top, we had in the numerator 2 left over, and the bottom, the denominator, they all canceled out. So I do want to do an example with the reverse where the numerator cancels out completely and we're left with numbers in the denominator. Okay? Hopefully that made sense. And if not, just bear with me. Here we go. Let's say we have 6 to the 2nd power over 6 to the 5th power. Okay, so we're going to start again with a visual first. So we're going to show it, and then we're going to talk about the shortcut. Okay, so 6 to the 2nd power means 6 times 6. And then 6 to the 5th power is 5 of them, right? So this is, again, the reverse of that first one was 7s. So here I have 6 over 6, so that cancels out into 1. 6 over 6, that cancels out into 1. So these are 1s, right? And then I'm left with 6 times 6 times 6 on the bottom. So this answer is 6 over 6 to the power of 3. Okay, it's cubed. Okay, so visually, that makes sense, right? It's easy to see how we get to that answer. The shortcut, if we start with 6 to the 2nd power over 6 to the 5th power, if we subtract, we get 6 to the 2nd minus 5, right? And when we simplify that, we end up with a negative power. 6 to the negative 3rd power. Which we don't want. So that again is like this. It's not a good answer. It's not a complete answer, okay? Anytime we have a negative power, we can flip it over the fraction sign. So 6 to the negative 3rd power is the same as 1 over 6 to the 3rd. So if it's negative in the numerator, then it's positive, the power is positive in the denominator, which gives us our last little piece of important information, okay? So we've got my last little asterisk. Anytime a power or an exponent switch above or below the fraction line, its sign changes. Okay? Make sure you get all of that. Anytime a power switches above or below the fraction line, sorry about that, its sign changes, okay? Its sign changes. So, if we have 8 to the negative 5th power as an example, okay? 8 to the negative 5th power. That is the same as 8 to the negative 5 over 1, right? Step 1, put it over 1. Anytime you want to make anything into a fraction, you put it over 1. Step 2 is now make the power positive. So that means since this is where the negative is, the whole thing is going to go into the denominator. So I'm going to have 1 over 8 to the 5th power. So now it's positive. okay, because it switched. It was on top of the fraction line and now it's on bottom, so the sign changes. Okay, let's say that we have 1 over a to the negative m power. Okay, so this is algebra. It's on the bottom where it's negative. It's already in a fraction, so all I need to do is bring it up, okay? So now I have a to the m power over 1, or just a to the m power. Okay? All right, I've got room for one more example. Here we go. Let's say we have 7 to the 5th power over 7 to the 7th power. So when I bring this up, I have 7 to the 5th minus 7, which is 7 to the negative 2. So first I'm going to put that in a fraction. So it's 7 to the negative 2nd power over 1. Since I don't want a negative, I'm going to take the whole thing, the whole numerator, and move it to the denominator. Running out of room here. So I'll bring it over here. So I'm going to bring it 1 over 7 to the 2nd power. And once it's in the denominator, once it switches above or below that fraction line, the power sign changes. So now it's a positive and my answer is complete. I do have office hours today, so if you have any questions, please jump on. 2:15. We can go over some more examples, or we can check some of your homework problems. Okay, make sure you're on the right track. Whatever you need, just let me know. We're going to be on page 85 for homework. Page 85 for homework, and I'd like for you to do numbers 6 through 22 even, please. Good luck.